Welcome back to our channel Acadecia. So far yesterday we have learned about straight lines, the introduction, and then today we are going to continue with next topic. So let's start with normal form. Okay, what do you mean by a normal form? Suppose this is a x-axis and this is the y-axis. And a line is there, a line equation is which is at a distance of P from the origin and the angle covered is alpha. So this line which is normal to the given equation, we have to find this equation which is normal to this line which is of P distance and its angle covered is alpha. So for this, the equation of the line in the normal form will be x cos alpha plus y sin alpha is equal to P. So this is a given equation. So the thing is, if any line which is of P distance from the origin and angle covered is alpha, then its equation will be in the terms of x cos alpha and y sin alpha is equal to P, where P is the distance from the origin. P is the distance from the origin and then alpha is the parameter, the angle which you use to rotate, okay? The angle covered is alpha, okay? Like this perpendicular form. So perpendicular form, suppose the equation of a line which is perpendicular to ax plus by plus c is equal to 0. So for this line, if any line is perpendicular, in order to find that equation, suppose this is ax plus by plus c is equal to 0. This is the line equation. For this, perpendicularly another line equation is there. For this equation, in order to find out this, what we have to do is you have to divide this equation with a square plus b square. You have to do this. Then you will get this perpendicular equation. Then this equation will be a by a square plus b square into x plus b by a square plus b square into y plus c by a square plus b square is equal to 0. Okay, this will be the perpendicular. On to the next, if we want to find the perpendicular distance from the origin to the line ax plus by plus c. Along with, if you have to find the perpendicular distance from any point P like x1, y1 to this line ax plus by plus c. So what are these formulas? You can simply remember. This will be mod c by root over a square plus b square. As a given point is there, what we have to do is you have to substitute this point in this equation. by1 plus c by root over a square plus b square. Okay. Simply here also you can apply this because here x1 and y1 are given zeros. Then simply only c coordinate will be there. So and here x1, y1 are there. We have to substitute in this equation divided by root over a square plus b square. Okay. Moving on to the next, symmetric form. In the symmetric form, suppose you have to find the equation of a line which is passing through x1 comma y1 and which is having an inclination called theta. Suppose if you are given theta as an inclination without means if you have to find the line, we have to follow two equations, two conditions. First thing, we have to know the slope, and second thing, we have to know from which point does it passes. Okay, and this point is known for you as x1 comma y1. Instead of slope, we know the angle. But simply, slope is nothing but m is equal to tan theta. Here theta is already given as theta only. So from this, you can multiply, you can substitute here m into x minus x1. This is the equation we have learned. Okay, and in this, substitute it as tan theta. Okay, tan theta we can write as sin theta by cos theta. So if you write like that, sin theta by cos theta, and bring the sin theta down. Okay, then you will get cos theta is equal to x minus x1 by, this will be sin theta and this will be cos theta. So this will be the symmetric form. If they are given a point and an inclination, simply substitute in the given equation. As we know, the slope is tan theta and the theta here inclination is parametric form. Means the parameter itself means in the name itself you can know the parameter means it will change. Okay, from this you can see from this equation only you will get the parametric forms. Suppose it is of a point P which is there, it's of x comma y which is passing through the point x1 comma y1 and has an inclination theta and this distance is r. Then have to find the parametric equations for that. In order to find out this, so simply apply this y minus y1 by sin theta is equal to x minus x1 by cos theta equal to the distance between the original point through which it passes, that will be r. So equate this individually to r. Then you will get y minus y1 by sin theta is equal to r sin theta. Then you will get y is equal to y1 plus r sin theta. Okay, similarly for x you will get x is equal to x1 plus r cos theta. So this will be the parametric form. This is a symmetric form. If we equate that to the distance r, then it will be parametric form. Okay, these are the four forms we have learned. Those are normal form, perpendicular form, symmetric form, parametric form. So these are the forms in order to write the equation of lines. Okay, we have completed normal form, symmetric form, parametric form and then perpendicular form. So let's move on to the new topic, concurrent lines. So what do you mean by concurrent lines? Suppose a group of lines which have only one point in common, then it will be known as concurrent lines. Suppose like this. These all passes through only a single point and this point is known as the point of concurrence. The point of concurrence, and these lines are known as concurrent lines. Suppose let's give this equation as a1x plus b1y plus c1 is equal to 0. Another equation a2x plus b2y plus c2 is equal to 0. a3x plus b3y plus c3 is equal to 0. So these are few concurrent lines we have taken. So the condition for the concurrent lines, these three concurrent lines are there. If you find the det in the sense a1 b1 c1, a2 b2 c2, a3 b3 c3 will be equal to 0. This is the condition. For the concurrent lines, if we take in these concurrent lines the variables det, then that will be equal to 0. Okay, this is one topic. Moving on to the next, suppose if we take any two lines, suppose this line is a1x plus b1y plus c1 is equal to 0 and this is a2x plus b2y plus c2 is equal to 0. These two are the lines given and this is the included angle is theta. So in order to find this theta, we have few formulas, that is cos theta will be a1 a2 plus b1 b2 by root over a1 square plus b1 square plus a2 square plus b2 square. Okay, along with sin theta will be a1 b2 minus a2 b1 by a1 square plus b1 square plus a2 square plus b2 square. Okay, and if you divide this sin theta by cos theta, you will get tan theta, that will be slope. Okay, that will be a1 b2 minus a2 b1 by a1 a2 plus b1 b2. Okay, so moving on to the next one. So I am going to explain the centroid and circumcenter and orthocenter. So first let's draw the triangles first. Okay, these are the three triangles. First, we will learn about the circumcenter. And this is the orthocenter. And this will be the centroid. So let's take three triangles. We will mention the vertices as well for each. A, B and C. So these are of the center of the triangles. The circumcenter will be the perpendicular bisector. So in the circumcenter, simply if you have to define the point of concurrence of perpendicular bisectors. Okay? If you bisect this BC line perpendicularly, okay, and this AB line and AC line also. So where these lines where it has only one common point, then these lines will be known as concurrent lines. We have already learned that. And this point of concurrence will be the circumcenter. So simply circumcenter is nothing but point of concurrence of perpendicular bisectors. Okay. If we define the orthocenter, then it will be like point of concurrence of altitudes. Okay, for this A and B and C, for these triangles where the altitudes meet each other. Okay, the altitudes meet each other, then that is known as the orthocenter. That point of concurrence is known as orthocenter. So simply orthocenter is nothing but point of concurrence of altitudes. If we move on to the centroid, we can define it as point of concurrence of medians. Okay? Sorry. This will be the point of concurrence and that will be known as centroid. And this centroid is denoted by G, and this is orthocenter and this is circumcenter. Okay, and this centroid will divide these triangle in 2:1 ratio. You have to remember that. Okay, and this orthocenter, it is denoted by H and the circumcenter is denoted by S. Orthocenter will be H and then centroid will be G. And now the relation between these three, it's H, G and S. Now the centroid divides the orthocenter and the circumcenter in 2:1 ratio. This is a standard form. I mean, if you remember, if they are given a centroid, and if they are given any of these two, like orthocenter or circumcenter, any of these two, in these two, any one is unknown, and if we know the centroid, then we can easily find the other one. This we have learned in the session formula. So in this session formula, this G, that is centroid, divides the orthocenter and the circumcenter in 2:1 ratio. If any of these three are unknown, you can easily find that. Okay, and another one, suppose if you take a right angle triangle. Okay, if you take a right angle triangle like ABC, in this, if B is the orthocenter, okay, if B is the orthocenter, then the midpoint of AC will be the circumcenter. Okay, circumcenter. Okay, this is the another standard form that we have to remember is, in the right angle triangle, if B is an orthocenter, then the midpoint of AC, the opposite side, that midpoint will be considered as a circumcenter. So if you remember these, if we have any out of three, any one unknown, you can use this. So before we have seen, suppose if two lines are given and this will be the theta, and this line is a1x plus b1y plus c1 is equal to 0, and this is a2x plus b2y plus c2 is equal to 0. So these two are the lines, and if we have to find the theta, we have find the sine theta, cos theta and tan theta. Suppose if these two lines are parallel, what will be the condition? It's nothing but a1 by a2 is equal to b1 by b2. Okay, and if these two lines are perpendicular, then A1, A2 plus B1, B2 will be equal to 0. These are the conditions you have to remember, because these will be applicable in any of the times in order to find the answer. And if these lines are coincident, then the condition will be A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, these three conditions are important because these are used somewhere in the part of a solution if you have to find. Instead of an angle theta, if these are parallel or perpendicular or coincident, these are the conditions you have to find. Okay. Moving on to the next topic, foot of the perpendicular. Okay, suppose a point P is there which is of x1 comma y1, and then foot is of h comma k, and this line it is of ax plus by plus c is equal to 0. So in order to find the foot of the perpendicular, what will be the formula? It's nothing but h minus x1 by a. See, h is nothing but the foot x coordinate, and then x1 is the px coordinate, and then a will be the variable of x. Okay, and then similarly this is the x coordinate, we have to write for the y. It will be k minus y1 by b. So b quotient, the y quotient, we have to write b down here. That will be equal to minus of ax1 plus by1 plus c by a square plus b square. Okay, this will be the formula for the foot of the perpendicular. If P is a point and Q is the foot and the line is AX plus BY plus C is equal to 0, then in order to find the foot, you have to remember this formula. Suppose you have to find the image. So same thing, you have to find the image. Suppose this, consider this P x1 comma y1 is there over here, and then if you have to find this image, then what we have to do is simply we have to add 2 over here. If you add 2, then we will get the image formula, and foot and the image will be quite similar, because see here, if foot it is of only single distance, 1 unit distance. If you have to find the image, it's of 2 unit distance. Okay, remember like that. For the foot it will be only minus, for the image it will be minus of 2 times. Okay, so suppose you have find the foot of the perpendicular, okay, from one point P of x1 comma y1 to a line of ax plus by plus c is equal to 0. So from a point to this line, if the foot is of h comma k, then you have find out the formula is there, that is h minus x1 by a and then k minus y1 by b. So similarly like that we have to find the image as well. Suppose instead of this line, if this point, the foot of the perpendicular from this point to the x-axis, suppose if this is the x-axis, then what will be the foot? Foot of the perpendicular, if a point x1 comma y1 is perpendicular to x-axis. So if the x-axis, in order to find the foot, it's simply x1 comma 0. Similarly, the foot of the perpendicular which is parallel to y-axis, then it will be y1 comma 0. Okay. Similarly, in the case of image as well, suppose you have to find the image, and this is a point where you have to find the image, and this line, instead of ax plus by plus c is equal to 0, if we take the x-axis, then the image will be, if we take the x-axis, then the image will be x1 comma minus y1. Simply you have to alternate the sign for the, if it is x-axis, you have to alter the sign for the y coordinate. Similarly, if it is y coordinate, y-axis, then you have to change the sign for the x coordinate. Okay, for if it is of x-axis and then y-axis, the foot is simply x1 comma 0 and y1 comma 0. As because this is already there on the x-axis, it will be x1 comma 0 and y1 comma 0. And whereas the image, it will be x1 comma minus y1 and minus x1 comma y1. Okay. Moving on to the next topic. Suppose if we are given 2 lines, okay, which is Lx plus my plus n is equal to 0 and ax plus by plus c is equal to 0. Okay, these two lines are there. In order to find the reflection of the line, Lx plus my plus n is equal to 0. Okay, this is the line Lx plus my plus n is equal to 0 and this is the line ax plus by plus c is equal to 0. In order to find the reflection of this line with reference to this line, then what will be this reflection? What will be this equation? So in order to find that, what we have formula is Lx plus my plus n by ax plus by plus c is equal to 2 times of La plus mb by a square plus b square. So this is the formula in order to find the reflection of a line. Suppose we have given this formula, you have given this equation as 2x plus 3y plus 5 is equal to 0 and with reference to this ax plus by plus c is equal to 0, in order to find the reflection of the other line, this formula you have to use and substitute the values here. And similarly, if you have to find the angular bisectors, angular bisectors means nothing but if any angle is there, if we are going to bisect this angle will be, suppose entire angle if it is theta, it will be theta by 2, theta by 2. If you bisect one angle, then this will be known as an angular bisector. So in order to find that angular bisector, suppose this is the equation a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. So these two are the equations given, and in order to find this angular bisector, the formula is a1x plus b1y plus c1 by a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 by root over a2 square plus b2 square. Okay, this will be the formula in order to find the angular bisector, and this is the formula in order to find the reflection of a line. Moving on to the next, Seva's theorem. Okay, Seva's theorem. Suppose if given a triangle like this, okay, vertices A, B and C, and we have D, E, F. Okay, these will be the midpoints. Then the relation is BD by DC. So from where we have to start and where we have to stop, we have to decide. So if we start from B to D, then you have to start again with the D only, because you have stopped with D here. So BD by DC, not CD. Okay, if we have to write CD, then sign will change. This is equal to, if we have stopped with C, we have to continue with C over here, CE by EA. Again you have stopped with A here, AF by FB. This will be equal to 1. This is the Seva's theorem. So what it is nothing but where we have started and where we have stopped, with that only we have to continue with the entire triangle. So this BD distance by DC distance will be equal to CE distance by AE distance will be equal to AF distance by FB distance. Okay, that all will be equal to 1. Similarly to this theorem, as we have inside the triangle, now let's Milanese theorem, it will be outside the triangle. Suppose this is the triangle is there. This is the triangle given. So here outside the triangle, now we will mark the vertices. This is as usual A, B, C, and this will be D, E, F. So these are inside the triangle, these will be outside the triangle. Then similarly BD, this is complete BD. Okay, BD, first BD, then DC. BD by DC is equal to, after we have stopped with C, then we have to do with C. Next CE. So we have to go up CE through EA. by EA. After we have stopped with A, we have to continue with that. AF by FB. Okay, this will be equal to minus 1. As this is inside, it will be plus 1. As this is outside, this will be minus 1. Okay, this is the Seva's and Menini's theorems. Okay, here we have few standard formulas. Suppose if you have to find the point of intersection between two lines, then there is a formula. Okay, suppose if we take the lines as a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So we have a formula. Basically it's tough to remember, but if you remember it will be easy. It's like b1 c2 minus b2 c1 by a1 b2 minus a2 b1. C1 A2 minus C2 A1 by A1 B2 minus A2 B1. This is quite difficult to remember, but if you remember, you can easily find the point of intersection between these two lines. Okay, similarly with the next topic, suppose if we have given a ratio between these two lines as L1 comma L2, in order to find the, suppose a point is given x1 comma y1 and the two equations will be similar to this. C1 is equal to 0, A2x plus B2y by minus plus C2 is equal to 0. So what it is the ratio of a line which divides these lines. Then we have to find the ratio that will be minus L11 is to L22. Suppose we have two points, x1, this x1 y1 and then x2 y2, and we have these two equations as well. So by which ratio these two divide? So it will be like minus L11 is to L22. L11 is nothing but you have to substitute this first point in the first equation. Then it will be a1 x1 plus b1 y1 plus c is equal to c1 is equal to 0. This will be L11, and similarly L22 will be a2x plus b2y, a2x2 plus b2y2 plus c2 will be equal to 0. So this will be L11 into L22. So we have to find the ratio minus L11 is to L22. Okay. And the another formula is given C. I'll read it out. If the coordinate axes are rotated through a origin in an anti-clockwise direction, if the PQ are their intercepts, those are made by the new axis straight lines, then what will be the equation? So what they given is, suppose this is a coordinate axis, and this coordinate axis, if we rotate this anti-clockwise direction or counterclockwise direction, if we rotate this coordinate axis, then the P and Q are the X and the Y intercepts. Then what will be the equation? The condition. The condition will be, suppose the intercept line, if it is of like this. This is the, when the intercepts are given, this is the equation we have to write. So if like this it is there, the condition we have to remember is 1 by P square plus 1 by Q square is equal to 1 by A square plus 1 by B square. A square and B square are nothing but here we can substitute, and PQ are the intercepts. So from this is the standard formula. This will not be used in many cases, but rarely few problems will come on this. Okay. So anyhow it's quite important only, but it occurs rarely. So if you remember this formula, it's quite easy. Instead of finding the intersection of two lines, instead of using the formula, you can simply substitute. Suppose these two lines are there. In order, as this line meets this line, we can substitute this YCX method is there. So, in order to find the intersection of two lines, YCX method is there. After that, if you don't know that, if you have a capacity to remember all these formulas, you can remember this and substitute the values, and directly you can get the point of intersection. And if the two lines and 2 points are given, in order to find the ratio between them, then minus L1 is to L22, and if the coordinate axis is rotated by 90 degrees in a counterclockwise direction, then what will be the new axis, and that will be the condition is here. So recap on what we have learned today. We have learned about the normal form and then perpendicular form, symmetric form and parametric form. These all forms we have learned, and we have learned about the perpendicular distance from the origin to a line ax plus by plus c. This we have learned. And from a point x1 comma y1 with the ax plus by plus c we have learned. And from the point x1 comma y1 and to the line ax plus by plus c is equal to 0, having an inclination theta also. So these all distances we have learned. After this session we have gone to the concurrent lines and we have seen the condition and the definition for that. After this concurrent lines we have completed the angular bisectors, and if two lines are there on the included angle theta, we have find the sin theta, cos theta, tan theta we have find out. And if these two lines are parallel, condition, perpendicular condition, and the coincident also we have seen the condition. After this session we have moved to the centroid and then circumcenter and then orthocenter, and the relation between these three. If any one is unknown, then we can find the other two easily. So relation we have seen, and in a right angle triangle we have seen the relation between the circumcenter and then orthocenter. This we have seen. After this we have gone to the foot of the perpendicular, and we have gone to the image as well, image of a point. So foot of the perpendicular we have seen if a point which is of ax plus by plus c is equal to 0. For this line we have seen a huge formula, and for the x-axis we have seen the foot, and for the y-axis, and similarly conditions for the image as well. If we have seen for the ax plus by plus c is equal to 0, and for the x-axis and for the y-axis individually. After this, angular bisectors we have already covered, and foot of the perpendicular, image. Okay, and we have covered the image or the reflection of a line. Image or the reflection of a line. If the reflection is there, in order to find the reflection of line, suppose this is lx plus my and this is ax plus by. In order to find this reflection, we have seen a formula like 2 of La something. So that formula we have seen. And after that we have seen about the Seva's theorem and then miscellaneous theorems. If a triangle is there which is bisected internally and which is bisected externally, then we have seen the Seva's and the miscellaneous theorems, and few problems about point of intersection of two lines are there. Then in order to find the point of intersection, some a1 b2 minus some, we have seen two formulas. Okay, for this, and if the axis is rotated by 90 degrees and we are having the x and the y intercepts as p and q, then we have seen a formula like 1 by p square plus 1 by q square is equal to 1 by a square plus 1 by b square. That formula also we have checked out, and the point of intersection we have checked out. And still if two lines are given and 2 points are given, in which ratio are they dividing? It is 1 minus L11 is to L22. This formula also we have seen. So this whole scenario we have covered in straight lines in today's video. So hope you like the video, and you have till here. If you have any doubts or any queries you have, please let me know in the comment section. And if you like the video, please like, share and comment and subscribe to our channel. Thank you.